A photobioreactor is an artificial algae growth environment. The general premise behind the technology is algae will use CO2 from flue gas, a byproduct of fossil fuel combustion, and use it to respirate and create sugars. The Center for Applied Energy Research is currently looking at ways of using this technology to reduce CO2 emissions and additionally sell the algae as an ingredient for biofuels and bioplastics. Team 2 was tasked to build and program a control system for the photobioreactor with the intent of keeping the total costs low for increased marketability. The control box, shown here out of its case, will be used to measure pH, conductivity, dissolved oxygen, and water temperature for two different algae banks. The system controls water and gas valves with relays. These valves control water flow, pH, and dissolved oxygen levels throughout the photobioreactor. The valve control is autonomous and depends on collected sensor data. A water pump is also commanded when to run and at what speed by utilizing a variable frequency drive, or VFD. The VFD is controlled by gating command signals with control relays. These command signals extend from water level sensors used to determine whether the algae banks are full and empty. The microcontroller receives and stores all sensor data and transmits all command signals to their respective control relays. The BeagleBone Black is the microcontroller that controls the entire system. The max output of the BeagleBone Black is only 3.3 volts, so this voltage must be stepped up in order to activate the 24 volt relays. This was accomplished using N-channel MOSFETs as an intermediate switch between the BeagleBone Black and the relays. To control the sensors and automatically change the state of the photobioreactor based on sensor readings, various software packages were used. MongoDB database is used to store sensor data and other various settings for the photobioreactor. To transfer data between the sensors, database, and user interface, a Tornado Python server is used. In order to display real-time data, a Twitter Bootstrap along with D3 graphs is used. Working behind the user interface is JavaScript. A touchscreen display is connected to the BeagleBone Black to locally view sensor data, manually control valves, and change control parameters. We are Team 2 Algae Biofuels Control System and include Gabe LePage, Nahom Mergia, Wes Flutie, Tyler Mize, and Matthew Steffen.